Hello everybody! Today I can prove segments are congruent by showing they have the same distance. So this lesson is going to be all about the distance formula. Distance equals radical delta x squared plus delta y squared. If you're not comfortable calculating distance, then go back to the calculating distance lesson. Number one, let's start by getting this on the graph. Let's get some better colors. Black's boring. Negative 3, 2 is A. B is 1, 7. C is 4, negative 1. D is negative 1, negative 5. And it wants us to prove that AB is congruent to CD. Something doesn't look right there. 1, 7, C is 4, negative 1, D is negative. Oh, I guess it looks right. So, there are two parts to a proof. In order to prove that AB is congruent to CD, I'm going to say that AB is congruent to CD because it has the same distance. To prove segments are congruent, we state that they're congruent because they have the same distance. I don't know why I wrote it, because they have the same distance. So I have to show that. So now I'm going to find the distance of AB, and I'm going to find the distance of CD. Distance equals radical delta x squared plus delta y squared. AB, 1, 2, 3, 4. 1, 2, 3, 4, 5. Delta x is 4. Delta y is 5. Add 41. DC, 1, 2, 3, 4, 5. 1, 2, 3, 4. 5 squared plus 4 squared. 25 plus 16. Rad 41. To prove segments are congruent, I have to show they have the same distance. I showed, what just happened there? I showed they have the same distance. That's a proof. So, to prove segments are congruent, I'm going to state that they're congruent because they have the same distance. I don't know what happened with my grammar here. They have the same distance, and then you're going to calculate the distance and show that they're the same. It's going to be the same thing for every single problem here. Well, I take that back, except if it says to prove that they're not congruent. Let's go orange. Orange. A is 5, 2. B is 8, 0. C is 9, 1. D is 7, 3. It wants me to prove that AB is not congruent to CD. There's actually a symbol for that. It's the congruent symbol with a line through it. AB is not congruent to CD because, well, it's the reverse of what we just did. If segments have the same distance, then they're congruent. If segments are not congruent, they don't have the same distance. So I'm going to say that AB is not congruent to CD because they don't have the same distance. So now I have to find the distances. And instead of showing that they're the same, I'm going to show that they're different. So let's start with the distance of AB. Distance equals radical delta x squared plus delta y squared. 1, 2, 3, 1, 2. 3 squared is 9. 2 squared is 4. Rad 13. Now I'm going to find the distance of CD. 1, 2, 1, 2. Delta x is 2, delta y is 2. Distance of CD is rad 8. Are they the same? No, that's the point. I wanted to prove they were not congruent because they don't have the same distance. I showed that they don't have the same distance. I'm done. That's it. There's not much more to this. We're going to go through 2 more, but there's really not much more to it. And we're going to be building on this in the next unit. We're going to work up into 6-point questions, and this is a component within the 6-point questions. All right, n is 2, negative 3. R is 6, negative 2. Q is 8, negative 1. W is 4, negative 2. NR, QW. It wants us to prove that NR is congruent to QW. So I start by writing NR is congruent to QW because I want you to finish that statement, finish that sentence, look back at the first example if you need a model. I want you to finish that sentence. NR is congruent to QW because it's going to always be the same ending to that sentence. Take about 15 seconds, try and finish it on your own. Okay, if I look back at number 1, I said that AB was congruent to CD because they have the same distance. So, same thing here, NR is congruent to QW because they have the same distance. So now I'm going to find the distances. I'm going to find the distance of NR. I'm going to find the distance of QW. Distance equals radical delta x squared plus delta y squared. You do it. Pause. Find the distances for NR and QW, and then unpause. Now that you calculated the distances on your own, let's see if you got them right. NR is 1, 2, 3, 4, and then 1. Radical 4 squared plus 1 squared is radical 16 plus 1 is radical 17. QW is 1, 2, 3, 4, and 1. 4 squared plus 1 squared is 16 plus 1 is rad 17. That's your proof. If they want you to prove segments are congruent, you say they're congruent because they have the same distance. It's always, always, always that sentence, unless it says to prove they're not congruent, in which case you say that they don't have the same distance. Then, either way, you're going to calculate their distances using the distance formula. And if you said that they were the same, they should end up being the same. If you said that they are not the same, then you're going to show that they're not the same. I want you to try number 4 on your own right now, so please pause. Try number 4 on your own, and then unpause. Okay, now that you tried number 4 on your own, I want something fun. There we go. Now that you tried number 4 on your own, let's go over it. T is 8, negative 6. A is negative 2, 1. C is negative 4, negative 3. O is 6, negative 10. It wants me to prove TA is congruent to CO. So TA is congruent to CO because they have the same distance. So I have to show they have the same distance by finding the distance of TA and the distance of CO. Distance equals radical delta x squared plus delta y squared. You really don't have to draw the lines in. I mean, there's nothing wrong with doing it, but you're basically just counting between them. So TA is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. That's 149. Radical 149. CO is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. Rad 100 plus 49 is rad 149. I show that they're the same. I'm done. It's all about practice. Again, we're going to build on this. This is going to be a smaller component within a bigger problem in the next unit. So it's really important that you practice it. So your classwork/homework is to practice. And I will see everybody next time. I hope you have an enjoyable day. Bye.